Hello and welcome everybody to number 5 of the very popular series 30 Minutes with Servoy, in which we, within 30 minutes or less, briefly discuss important topics in the Servoy programming environment. We talk about new components that we are releasing as open source and free components and other interesting things that you should be aware of as a Servoy developer. Today, again, a very interesting topic. Before we get started, very briefly, Servoy World has been announced last month, and these are the last weeks that you can still get the early bird discount to get to Amsterdam. So it's May 17 to 20, really the greatest place to learn about Servoy and meet other Servoy developers, meet the Servoy engineers, meet Jan, who's the main presenter of the series so far, and interact with other Servoy developers. It's going to be in Amsterdam, great location in the center. Also keep in mind that right now booking flights to Amsterdam from most parts in Europe and other parts in the world, including the US, is pretty cheap. I've seen flights from the US as low as $350 two ways to Amsterdam, so back and forth. To find your flights, I recommend flights.google.com. It really gives you a flexible and easy way to find all the different flights and how much time you wish to spend on a plane. All right, with that out of the way, let's get started. We only have 28 minutes left. I'm going to hand over to Sean, who is going to present today's session number 5. Welcome, Sean.
Thanks, Jan. My screen is visible. You can see the slide.
Yes, thank you very much.
Okay, just checking. So this is number 5 in the tech series, which we started towards the end of last year. And apart from a holiday break, we've been really sticking to the every 2-week schedule, and we're going to try to do that no matter what life throws at us. So today, January 11th, we're switching it up a little bit. So in the past, we've been announcing open source modules and web components and new stuff, and we will continue to do that. However, we also want to make this a bit of a learning, not just about what's available, but also learning regular things in Servoy and best practices and how to do things. We have a topic today about saving records, saving data in your applications, and this is really coming from my experience and my colleagues' experience when we work with customers. A lot of times we see problems just in the part where they want their applications to save a user's edits or something like that. So today we're just going to be focusing on a few key topics there. We're going to talk about handling failed saves, so when you try to save data but it's maybe rejected by the database. We're going to be talking about using database transactions and sort of the correct way to do that. Also, if you choose to do record locking, the correct way to do that and to deal with conflicts. And we'll talk about doing batch updates as well. So first, let's do a bit of demo, and then we'll come back and review what we learned. So I have in my browser a small little application that I've built, and you can see that across the top I have 4 different save icons because we're going to go through a couple examples. In the first example, when I edit something in my screen here, in this case I'm going to choose a product that is already on the order. Now this is the sample database that ships by default with Servoy, and this particular table for the order details has a composite key, so you can't have a duplicate product. I don't have any business rules in my application. This is just to make an example of when I try to do something as a user, and maybe this should have been checked by the programmers first, but for whatever reason it gets through and we try to save it, the database is going to reject it because it's a key constraint violation. In my first example, I click save and nothing happens. The record is not saved. The user doesn't know that it wasn't saved. Nobody knows that it wasn't saved. In fact, the record still has that change on it in memory the in-memory transaction in Servoy. So I can cancel this, and you can see that it rolled back to the apples. Now, this, despite how bad it looks, is quite common. And I'm going to switch into the code for just a minute and go to the first save method here called save1. I see this all the time. Just database manager save data, or maybe save data with a record or a found set, because you can save everything that's in the in-memory transaction, or just a particular record, or all edited records in a found set. So what happens when save data returns false? It doesn't throw an error. It doesn't alert you. There's nothing that you see as a user. This method does return a Boolean, and it would be false, but in this case I haven't even chosen to handle it. I just optimistically say I'm going to save data and everything's going to be okay. The only indication that there's a problem is if we go to our log and we look at the server log. You can see that there's some indication that a duplicate key constraint was violated. And so when I'm helping customers troubleshoot a problem, we'll typically start with something that happens. Maybe that record wasn't saved, and later there's another problem, and it's not even evident that that record wasn't saved at first. Something else later happens that now becomes weird, and then we go, okay, well let's look at your log, let's see what's going on. Oh, we see this error. When does this happen? Oh, I don't know when this happens. So long story short, save data returns a Boolean. You should always use it. You should never call save data without evaluating if something actually saved. So let's go ahead and let me scale this back down again. Let's do another save here. This time I will again break the database rule of selecting the something weird here with my type ahead. There we go. So I'm going to again break the duplicate key constraint, and I'm going to try to save. This time I have a bit of error handling now, and I've printed it out to the user. It's not the most beautiful error, but this was not an error that I expected. This was an error that came back from the database, and at least I know immediately there's a problem, and I can call tech support or whatever. It's evident that for whatever reason the record failed to save. Let's go in and look at the code for that. This time we have save to, which is hooked up to that second save button, and all I've done is I attempt to save. I put this in an if statement, and if I fail to save, then I have some code here to notify that there's a failed save. When database manager save data returns false, the next thing you can do, if you want, you could just print up a message to the user and say, record failed to save for an unknown reason or something. If you want to inspect it a bit, you have complete control over the in-memory transaction that's happening in Servoy, and you can use the getFailedRecords method of the database manager API, and you can iterate over those records, and every failed record should have this exception object. In the case of a failed save, it's usually a data exception, which is a specific class of exception which has some methods. So I did a cast here, and you can see some of the methods that are available for that kind of exception. In this case, I've chosen to print either the value or the message in the exception. Sometimes it's one, sometimes it's the other, so I picked either one that's not null, and I printed it out to the user using the web notification service. So at least you should do, if not, save data, show a message, throw an error, whatever, but don't just assume that it saves and everything was good, because you won't find out right away. You'll find out later, and it will be really hard to trace back to the original problem. Okay, let's do another example. This time I want to show how how you can also handle errors on saves that maybe you produced on purpose. In the case of table events, we can also generate save errors and then handle them in the UI. I'm going to open up my order details table using the resource locator. And in the table editor, I'm going to go to the events on that table. And you can see that I've implemented 2 event handlers for inserts and updates. There's also one for deletes as well. These events fire both before and after, so the on-record insert, update, delete happen before the change is actually submitted to the database through SQL, and then the after events happen afterwards. That's, I think, a subject for a different webinar someday. After record events are usually used to handle cascading changes that you might want to do when a new record's created over here. Maybe I create 5 related records over here or something like that. I'm just talking about the pre-events, which allow you to actually block the action from happening, which will result in an error. So we'll pick either one of these because I do the same thing in both of them. And you can see that on the on-record insert event handler, it passes in the order details record, and I've created a little private method to validate order total. Now there's an arbitrary business rule here that the whatever I'm modifying on the order details, the total, which is the calculation on that order, can't exceed 50,000. So if I change the unit price or the quantity or to add an item, it doesn't matter. Either of these events will fire, and then I'm going to say, if the order total is less than 50,000, I'm just going to throw an error here. Also, returning false will also block the SQL from being executed, but in that case, I don't get this message back on the record exception. I would just get a save data failed generic thing, and I can't actually see what the problem was. So this is kind of your last line of defense. I'm not saying that this is the best way to do all validation and gives you great UX, but I have a business rule. I can't exceed 50K on an order, and I don't want to allow any data change that's going to make that happen. I could maybe handle this earlier and not wait till they save the data, but that's a different topic. That's just about UX. This is about the hard business rule that this won't go into the database and it will produce an error. So back in my my save data or my save to method, the one that's actually checking to see if it failed, when I iterate over those failed records, even though the database doesn't reject it, I will still get that error back in my records exception, and I'll be able to show it to the user. And in this case, because it's coming from me, it's a lot nicer than some SQL exception from the database vendor. Let's try it out. So again, I actually haven't. I still have these duplicate products here on this order. The save never happened. I could do a revert, and you would see it would go back. But again, I'm going to select the duplicate. Oh no, we're doing the business rule. Sorry, I'm going to change the quantity on this from 4 to 400. I'm going to tab out, and you can see with the calculations fired, my order total's gone above 50,000. I haven't yet tried to save, so that doesn't produce an error yet. But now when I do the save event, you can see that a change in items caused the order 10249 to exceed the 50K limit. And so again, the SQL was never sent to the database. The record is still modified in the in-memory transaction, and I can go and I can revert it back to 4, and you can see that it went back down. So that's an example of how your own errors can also be attached to that record in that exception when save data returns false. So that's a good start. However, there's a situation where the way that I've written that still might give a bit of an inconsistency in the UX. And the example that I'm going to give is I'm going to modify the sales rep, and I'll change it to Margaret Peacock. And I will also exceed the 50K limit by making the quantity 400 again. And I'm going to try to save using that same method. So I get the error, which is great. However, now I'm going to go ahead and say, okay, I'm going to cancel this, and I roll it back, and you can see that the quantity went back to 4, but the sales rep did not go back to the original value. That's a different record. This is the order record, and this was the order detail record. So it's important to know that when you call save data and you have more than one edited record, it's gonna commit all of the records that it can, and any records that fail are going to be marked as failed. So if you had 5 edited records and 4 of them committed successfully and 1 of them failed, save data will still return false, and then you'll be able to look at the failed record. Now, in some cases, that's ideal. In other cases, it can give a bit of a weird UX, and I think this is one of those cases, because I assume that when I click save that nothing's going to happen if there was a problem. And in fact, something did happen. I saved 1 record, but not the other. So the only way around that is to, because you don't know that a record failed until you try to save it, the only way around that is to do this inside of a database transaction, so that if any of them failed, you can go ahead and roll everything back. So let's do that. Let's do this change one more time, and I'll save it through a transaction. You can see that everything was able to be rolled back. So I'm going to go ahead and change the sales rep again to Janet Leverling, and I'm going to exceed my 50K limit again, and now I'm going to use a third save method. And you can see I get the same error because I'm running it through the same notification subroutine. But now when I roll back, you'll see that not only will the quantity go back, but the sales rep should go from Janet back to Margaret Peacock, or Andrew Fuller. That was the original value. And you see that it has. So even though one of those records, the save was okay, it's still wrapped inside a database transaction. So when the other record failed and I caught it, I can roll everything back. Let's take a look at the code. So I have a third method called save3 that's hooked up to that third save button. And in this time, I am using the Database Manager API to start a transaction. Now, when you start a transaction, it means that everything that happens within that transaction can be committed or rolled back together. One of the first things, as far as best practices go, is that the moment you open a transaction, you should surround all your code in a try-catch or try-finally until the transaction's rolled back or committed. Another best practice is that you shouldn't open a transaction that you don't intend to close in the same thread, meaning don't have a button that runs a method that opens a transaction and then the thread dies, and then the user is now in an open transaction. They can do other stuff, and you're relying on some other event to close it. They should open and close, and transactions should be open as briefly as possible. So you don't want to open transaction, run a bunch of code, and then try to save data. You really want to open a transaction right at the moment where you're going to save things, and then you can commit it or roll it back. So I do the try-catch block. Now I do the same thing as before. I call save data in an if. If save data fails, I warn the user, and then I roll back my transaction. Now, rollback transaction has some options. You can see I put false, false. If you want to also roll back edited records and revert records that actually would have been saved, you can do that. In this case, I chose false because I want to leave all the edits on the screen, and then I can manually hit the cancel button to roll it back. It also makes for a nicer demo. So I've handled the failed save. I notify the user, and I rolled it back. If this never happened, I move on to the next thing, which is I try to commit the transaction. Now, commit transaction can still return false if there was a problem. In that case, I want to throw another error because I still want to make sure that the transaction gets rolled back. If everything went well, the transaction was committed, I notify the user that there was a success. Down in the catch block, I can handle any runtime error and roll back the transaction and notify the user that there was a problem. I should point out that I'm not just catching the error that I threw here, I'm catching any runtime error. So if I have a programming mistake and at some point I get like a null pointer problem, whatever that happens, that will kill the thread unless it's caught. And if I open a transaction and then I had some JavaScript error, the thread dies and the transaction is left open, and now I could get deadlocks on on my database, and that's not good. So that's why I'm doing a catch the moment I open it. Another way this can be done is with a try finally. Some people will roll it back in the finally. So that's a matter of, I think, personal preference. The point is that that you're rolling it back either in the catch or the finally, if there's any problem. Okay, so that's saving in a transaction. I have another example. Some people are using record locking, so I want to make sure that that is also demonstrated a best practice. So record locking is where you have two different client sessions in an application server, and maybe they're both looking at the same record, or maybe it's just a batch operation that's doing things programmatically. It doesn't matter. One client says, I'm going to get a lock on this record or this group of records in a found set. And at that moment you get a lock, another client cannot try to modify those records. Now you can modify them in the in-memory transaction, that's fine, but you can't save any modifications if a modified record has been locked in another client session. So I want to simulate how this might happen, and to do that I need two clients. So there's only one debug client and developer of each variety, so I'm going to use the smart client, and I have that running here with another form, and I'm looking at the same record, the order to Bees Beverage in Münster, Germany, and I'm just going to click the lock, and that has acquired a lock on the record. Now when I go back to the client here and I attempt to save with this fourth method, it's going to fail because there was a lock. You can see record is currently locked. So if I switch back to my smart client, let's say whatever operation was happening here, it released the lock, and now I can come and I can save, and it would say all changes saved. So the lock wasn't blocking the edit from happening. So let's take a look at the code briefly. Come in here to my save for method, the one that does locking. What I've done is I created a little subroutine here to acquire the lock with a timeout. This is just a trick that I like to use because in actuality locking should be just like transactions, should be as brief as possible. You don't want to lock a record and then do a bunch of other things unrelated to that record. You want to lock it, and then save it, and then release it. So I've locked the record in a timeout here, which means that if I fail to get the lock the first time, I'm going to keep trying up until a certain limit, and then I'm going to just give up. I think that's a nice way to do it, because it may be that the other client that locked that record was just chugging through a list of records, locking them, doing some things, and saving them, and that lock maybe was acquired for just a few milliseconds, but I happened to get it at the same time, and it caused this error in my application. And what I'd really like to do is just wait for a few seconds or a few milliseconds, whatever it is, and then try again. So I made this little method which takes an argument for the number of milliseconds and returns true or false if it was able to get the lock. And really we're just calling database manager acquire lock on this found set, and 0 indicates that it's the selected record we want to try to lock. So just like the other methods on that API, acquire lock returns a Boolean, and it will be false if you weren't able to acquire the lock. So we're not throwing errors in the core APIs of Servoy. We're letting you handle it and choose to throw an error or not. So back to my save for method. If I don't get the lock within the timeout, then what I'm going to do is notify the user. Otherwise, I'm just going to default to the other method where I saved with the transaction. Again, you want to always do things in a try catch or a try finally. Here I use a finally because I don't care what happens. I just want to make sure that the lock is released after I save. Okay, so let's change the timeout, and I don't know, we'll do something really long, 30 seconds, which will give me time to unlock it while it's still trying to save, and you can see what that's like. So I'm going to go to first my smart client. I'm going to lock it there. So now the record's locked, and I'll go to my web client here, and I'll change the I don't know, the sales rep. And now what I'm going to do is I'm going to try to save, and I have 30 seconds before it's going to give up. So while it's trying to save, I'm going to switch back, and I'm going to unlock this. As I switch back here, you can see that the change was committed. So as soon as it was trying, it was waiting, it was trying, it was waiting. As soon as that lock was released, this client was able to grab it and make the change and commit it. So that's one way to think about locking. So you can do it in a timeout so that you don't necessarily fail if the first try failed. I should point out that this was going through the other save method. So even if I had a problem, say I put this again to 400, I break my 50K rule. I'll change this to Margaret Peacock, and now I'll lock it over here, and I save it over here, and it's waiting, and I come back and I release the lock. You can see that here I still got the error. It still went through all the same channels, and the table event was called on record update. And it also happened in a transaction. So now if I cancel, you'll see that the sales rep will also roll back too. So it's still taking all the other best practices that we had in the other examples. We're running up on the time limit. There's one other thing we wanted to go over, which is doing batch updates, because I see this sometimes as well, and I want to just point out a couple things in our APIs. So I'm going to go to the different form here, the products form, and I just have, say, I don't know, arbitrary business case that if I change the unit price on a product, I want to go and take all the orders where that product appears and update the unit price on the order details. It's an arbitrary thing, but it shows us an example of a batch update. So I'm going to change the unit price to 100 and tab off, and you can see that I get a question: do you want to update all the order details referencing this product? And I click yes. And they were all updated to 100. I want to show you the code because there's a bunch of different ways to do this, and I want to show you what I've chosen to do. So I'm going to go to the on data change handler of that particular unit price field, and I want to show you what I've done. Once they confirm it, I have an entity method, so it's actually implemented on the product found set itself. So I'm separating my logic from my UI a bit. And so if I jump inside this update order details iterative method, you can see that I use the get found set updater API. And then I use the iterator, and so it basically goes over every record in the found set and sets the column. The found set updater API has kind of two different ways to use it. I'm using the iteration way, and that's the reason I've done that is it's a safe iteration, so the record set that I get is not going to change. If I do something and say it's sorted by unit price, and then it shows up in a different place, or I'm deleting records and then now it's changing the actual size or selected index. This is like a safe iteration, so it basically just goes over the list and I can change every column. I should point out that this does it on those records in memory, and nothing is committed to the database yet. So when I come back here and I choose to save, I'll just choose with my third save one that does the transaction. You can see that some business logic was still fired, and I believe, actually, I think that was over here. Let me roll this back, which rolls everything back, because I don't think it should have fired yet. So I do the 100. That's the reorder level. I do the 100, and then I say yes. Everything was changed, but it's not yet saved, and now I can save it. Oh, we do have one of these that exceeds 50K. I don't see which one it is, but one of them does. The point is that that it only updated the records in memory. So now when I save, everything still went through that table event. And so one of those orders was violating my rule. So I can't save it. There's another way to do the update. You can see that I've written a second method here, which also uses the iterator, or the updater, but it doesn't call while updater.next. It just does set column and perform update. And that's entirely different. Although the outcome is the same, it actually does a SQL update, like update order details where product ID equals my current product ID. So that's one query. The performance is much better. There's a lot less overhead. The downside is that it will happen immediately without doing any table events or auditing that I might have set up. So if I switch my implementation on the data change event handler, and I do the immediate one, not the iteration one, so I'll set this to something really big like 10,000, and I say yes. You can see that a lot of orders. Oh, that was 1,000. I'll do 10,000. So we really make a lot of orders to break that rule. So now a lot of orders have broken that 50K limit. The data is actually saved. If I click roll back, nothing happens. The data is saved immediately, and I didn't get a chance to run it through my table event. So that's just one thing you should know. If I look at the query statistics, you can see that update down here, where it's updating order details and setting the unit price where product ID equals. And that's a much more efficient query than looping through the found set, but the downside was my business logic got short-circuited. So you got to know that when you're choosing one or the other. Okay, we're really running over time. I was going to kind of review this stuff in slides, but I'll just post the slides on the forum. It's really just kind of reviewing what we covered. I want to leave time for questions. Jan, do we have any coming in?
Yes, we do, Sean. There is a question from Juan Santana, and his question is, does all this mean that as best practice you would avoid using autosave mode on?
Right, yeah, I kind of forgot to mention that if you look at the on solution open event handler for my solution, so got to get my GoToMeeting thing out of the way. So over here in the properties, you can see that I handle the solution on open event, and I'm actually setting autosave to false right here. The other stuff was just ignore that. Right here I'm setting the autosave to false. So auto commit is on by default, meaning your records will get saved kind of as you click around, and you don't need to explicitly call save data. But that's kind of out of scope for what we want to talk about, because a lot of people use autosave, and when they do, I see a lot of the save data without handling and all that stuff.
So would you consider it best practice to have it turned off by default and do your own error handling, or?
Well, it's up to you. The table events still apply, and if autosave is off, though, then you have to handle errors differently. And most common, I see that autosave is, when autosave is on, you have to handle it differently. Most common, I see that people turn autosave off because they really want control. They don't want the user to have the experience that everything they do is saved, but it's really a UX thing.
Okay. There's a question from Steve. By the way, if anybody has last-minute questions, then post them now on the questions channel. There's a question from Steve. Is the sample solution available for download?
Yes, Steve. I'll just click forward to one of my slides here that we should show. Some useful links. There's a link to this series where you can get a recording of this. Questions and ideas and feedback can be posted on the forum or emailed directly to us. And this example solution I will upload to the GitHub repository where we put example solutions, and that's that third URL right there. It's where we've put examples from past webinars as well. I really encourage you guys to make GitHub accounts, and when you encounter some of the repositories that we're sharing in these webinars, if you have a GitHub account, you can watch a repository and you can be notified when things change as well.